Assalamualaikum warahmatullahi wabarakatuh. My name is Salwa from Faculty of Economics, University of Sulawesi Barat. I want to explain about effect of climate change on biodiversity in tropical rainforests. Introduction. Tropical rainforests are one of the world's most valuable economics as they are home to most of the planet's biodiversity. This ecosystem supports a wide range of plant, animal, and microorganism species that are unique and not yet fully understood by humans. However, global climate change, such as global warming, changing rainfall patterns, and increasing temperature, have led to instability and change in the tropical rainforest environment. Method 1. The island model integrated model of land surface process was developed using IBIS Integrated Biosphere Simulator Foley et al. 1996 to represent process at the Earth surface. The main focus of the island model is to present Brazilian economies and South American tropical biomes. 2. The regional ET model is used to downscale climate scenarios. ETA is a numerical atmosphere model used to produce weather and climate forecasts for South America by the Brazilian National Institute for Space Research (ENPE). A climate change study version was developed by Pesqueira et al. 2009, Gu et al. 2012 to support Brazil national communication to the United Nations Framework Convention on Climate Change. 3. Using the same methodology as Lira et al. 2016, the England model was forced by regional ET model run under two RCP scenarios. Under the RCP 4-5 scenario, radiative forcing increases almost linearly until around 2060 when the rate slows down, eventually stabilizing by the end of the century. 4. The change in forest area predicted by the island model was assessed by comparing the percent tree cover in the last 10 years of 21st century with the percent tree cover in the 10 years between 1916 and 1970. Result and discussion. Climate projection provided by ATHGMA2 show warming of about 3 to 3.5 Celsius in the region under SCP-4-5 Fig 2A and about 6 and 7 Celsius under SCP-8-5 by the end of the century Fig 2B. Reduced precipitation dominated the future simulation, especially in the lowland regions of the Pacific and Caribbean watershed in all countries, Guatemala, El Salvador, Belize, Honduras, Nicaragua, Costa Rica, and Panama. This drier future trend is partly inherited from the HGME2ES driving model, which shows a reduction in future rainfall. Both RCP-4-5 and RCP-8-5 land model projections show reduction in tropical forest cover, with higher reduction in RCP-8-5 scenario Figure 5. Countries such as Costa Rica and Panama, which have relatively large annual rainfall, show little change in tree vegetation cover. However, countries such as Nicaragua, Honduras, Guatemala, and southern Mexico show a large decrease in forest cover in the Caribbean watershed. These results are in line with the increasing duration of the dry season in the region. The project area of tropical rainforest will decrease as the simulation approaches the end of the century, and this projection differs between SCP-4-5 and SCP-8-5. These results are similar to those of Imbach et al. 2012, which were generated using an equilibrium model approach. Imbach et al. 2012 observed phase dry Pacific watershed ecosystem expanding into the southernly, more humid Caribbean region under future climate scenarios. Impact at 2012 also found significant impact on increased YUE on vegetation response to CO2 fertilization and areas of potential total tree cover loss. Areas originally covered with savanna and tropical deciduous forest vegetation are practically extinct by the end of the century. Conclusion: dynamic vegetation models were driven by downscaling climate change scenarios to assess potential impact on tropical rainforests in Central America. Dry future scenarios indicate the conversion of tropical rainforests to savanna and grasslands. This result have implicated for CO2 feedback to the atmosphere. Change in temperature and precipitation may exceed the natural adaptive response capacity of rainforests, leading to forest loss, seriously impacting the global carbon cycle. In addition, Central America is highly dependent on water resources, and forest loss could lead to regional and local impact on water availability and quality.